Szanowni Państwo, czuję się zaszczycony, że mogę zapowiedzieć pierwszy wykład plenarny w tej dzisiejszym dniu tej konferencji. Otóż wykład plenarny wygłosi pan dr Said Taha, który jest wiceprezydentem wydawnictwa Elsevier, jednego z największych, jednego z najstarszych wydawnictw naukowych na świecie. Założone w 1880 roku, obecnie wydaje ponad 2,5 tysiąca tytułów naukowych, wydało ponad 33 tysiące książek naukowych. Tytuł wystąpienia pana prezydenta, pana doktora Taha brzmi The Research Landscape in Poland, National, Regional and Global Analysis. Dr. Taha, I invite you to give a lecture.
So, I know that I'm the only thing that is between you and the coffee, so I'll try to be as brief as I can. First of all, Prime Minister Gowin, Rector Daczynski, and Professor Daczynski, thank you very much for inviting me to be part of this conference. It was a breath of fresh air, and I mean that. Coming from the New York, when debates are about the importance of science and facts. And it reminded me that we should not take for granted the fact that science and research excellence is core interest of the government. Please don't take that as a granted thing. What I will try to do today is to give you a bit of a view on where Poland research is. And we will try to spark questions to help you throughout the conference ask the right questions as you go through. A bit of text on why I am speaking here and why we believe that we can help the Polish research excellence framework succeed. So, in quick terms, what I will try to do is I'll give you a little bit of data background on what sort of data I'm going to show you. I'm going to show you a lot of numbers. I'm a number geek. I'm very proud of it. So please, after the sessions, stop me at any point in time. I'll be happy to speak and elaborate on any of those numbers. I'll show you some of the projects we have worked. I have personally been involved with nearly 100 countries. I have been Elsevier with for now 14 years. All of them working on research intelligence, research management. We have worked with many countries. What I have heard today is the exact same challenges we have seen in most of the countries around the world. And we have managed to go and work with them and help them succeed. I won't spend too much time on the pretext, but just to give you an idea of why we are here. Elsevier has been operating in the world for 325 years. We have our own journals, which is nearly 2,500 journals. And in Scopus, we have around 22,000 journals, the largest abstract and citation database in the world. And accordingly, most of the analysis you will see today is coming from data based on that. This is just to show you the data assets we have. It's not only that we use Scopus. We use patent data that is the largest in the world. We have funding data that comes from nearly all the funders across the globe. We have usage data. The researchers use Scopus, use ScienceDirect. Nobody else can use and analyze that data. We have institutional data. We have the documents, and we have the researchers' data. I'll show you some very interesting analysis as we go through the day today. We have developed this set of tools to try to help analyze and work with universities and countries to see the right metrics for them to assess their own research. A quick view to give you just an idea why we believe we are best adapted to do this. If you look at Scopus, Scopus alone covers nearly 248% more Eastern European documents, research, articles than any other database available in the world. 250%. So we cover around 1,400 journals, while the closest in the world covers around 600. And the data that I'm going to show you today is making and giving the analysis based on that. Some of the tools that I will show you today are state-of-the-art technology applied using HPCC, which is high-performing cluster computing systems. And these are some of the partners we have been working with across the world. So if you see here, Prime Minister Guven mentioned ranking as part of the world's attention now. And we are exclusively working with nearly all the rankers in the world. Times Higher Education, QS, US News, Wall Street Journal, Shanghai Ranking, you name it. All of them are now using Scopus data because of the scale, the depth, and the coverage. This is a very nice example of metrics. I usually give this example very quickly to show you how science is informing aspects of life that has nothing to do with science. We were requested to do an analysis for the city of Amsterdam by urban development companies who want to build skyscrapers. A skyscraper costs a few $1 billion. A company wants to build that skyscraper in a place that is sustainable and that they know is going to be there for a long time. One of the metrics they look for is a university that is strong in research. So we made an analysis giving them the data of how strong Amsterdam compared to Barcelona, compared to another 10 cities in biomedical research, to give them proof that their investment in skyscrapers in Amsterdam is worthwhile. This is how impactful science and science metrics are from an investment attraction perspective. We have worked, and I'm giving only one example here, with countries around the world to help them assess their scientific performance. This is what we call the BIS report, and I will show you snippets of modes of analysis today that I have applied on Poland, taking some of the models we did with the UK. We have made this report comes out with the UK every 2 years. We also work with the Australians, with Italy, with Japan, and so on and so forth. I'm showing you India, which is one of our last partners. And one of the challenges all those countries also face is how to attract, first of all, the right funds, how to correlate with companies, industry, in what is called the triple helix, as we call it in the US, which is the academic, government, industry triple helix. So this is just to show you an example of what Texas as a state has asked us to do. They asked us to profile the researchers and to make their profiles public so that they can be identified by industry, so that industry understands who is available in a certain university that can help them with the research. We have applied what is called fingerprint technology so that when a company wants to understand who is the best person to work from a university with that company, they can find him in a click of a button, and that is publicly available data. We have done the same for the Ministry of Italy, where we profiled all the Italian researchers around Italy so that we expose them to the world and they would be discoverable. Before jumping to the data, we have learned throughout the history of working through these years is that there are a few golden rules about metrics. The first rule is qualitative understanding of metrics is of utmost importance. Quantitative is core, but the qualitative interpretations can never be done except by the academics themselves. We give you the data and you analyze it. You look through that data and you try to interpret it. The second golden rule is don't use one metric. We have learned in very bad history over the last few years that using one metric, like a journal metric, for instance, can skew the whole process of performance. And that is incorrect. Today, because it was covered quite a few times in the discussions, the aspect of how to normalize, how can I compare mathematics to medicine? We have worked with the Russell Group to identify what is called snowball metrics, and all the analysis I will show you today is going to cover some of those. The most important two metrics I will talk about today is what we call field-weighted citation impact, which is normalized value that can make me compare mathematics to medicine. What we do is that we look at the normal pattern of citations in mathematics, and we take one as an average for that pattern. And if somebody receives 20% more, his score is 1.2. If somebody receives 20% less, his score is 0.8. In this case, I can aggregate scientific research and I can compare like for like. But having said that, and as I just mentioned, you should never look at single metric. So we also looked at citation per publication. People don't like small numbers, so field-weighted citation impact is always between 1 and 2 or 0 and 1. But also it is hard to propagate. It takes us a lot of terabytes of data to be able to give you that outcome. So citations per publication can help you look at that into a little bit of context. I'll continue refining that as we go. This is one thing that we just launched, and I thought it's important to share with you as well, which is a journal metric that we launched for free as of 3 weeks ago for any journals that are now in Scopus. You do not need to have subscription to Scopus to look at that. And you can see here some of the journals that are published by the Academy of Science, where the rankings are updated, and this is based on what I mentioned, the biggest Scopus data set available. So please do try to use it if you would like to. It's, as I mentioned, free. Now let's go to the part I like the most, numbers. So this is one of my favorite quotes. My aim here is to help you ask the right questions. Because if you ask the right questions, the probability is you will get to the right answers. So I will spark questions, and my conclusions will be only questions. This is where most of you know these numbers by heart. If you look at Poland on this slide, you will see that Poland is now around 0.94% spending in GDP. It's a small left-hand side cornered circle. The size of the circle represents the actual dollar value in absolute terms. What you also see here, which is quite interesting, is that countries like China and Japan are spending significantly high amounts of their expenditure from a GDP perspective, while one of the highest in the world seems to be Israel and South Korea. So a small context. South Korea last year spent 4% of their GDP on R&D. And it is now spending more than any single EU country available, except for Germany. If you take size of those two countries into account, that gives you the indication of how much South Korea is putting there. India's investments in R&D has increased globally to the extent that they moved up 4 points in the rankings from the 10th position to the 6th position. And the US R&D spending increased from around 2.3% last year compared to China that grew around 7.7%. That has been more or less the same number that China has been growing in the last 5 years or so. So what does that mean? The GDP of Poland has been doing magnificent. And this is what I call the Polish paradox. Poland currently is at a state where it is high middle income country. It's the point of springboarding, as I call it. You are in a very good spot either to springboard your current position to become one of the highest nation income countries in the world, or you maintain your position. And over the years, that growth did not come easily. And I will show you today that you have done some magnificent progress. So You have a huge, strong heritage in science. You're a very strong scientific community, and that is a reality. If you look at it from the days of Copernicus and Marie Curie, Benoit, you see that you have done quite a lot of input into the scientific domain. Having said that, there are a lot of challenges as well. So the stated aim, if you will, by 2020 for Poland was to be around 1.7% of GDP in R&D perspective. And you are currently at 0.94. I'm giving you some context about some similarly sized, similarly scientific global economies. So if you look at Malaysia, now they are spending, in comparison to you, they're spending 1.13%. If you look at Portugal, they're spending 1.3%. If you look at Hungary, and I will try to emphasize Hungary, as I heard it mentioned quite a few times today, they're spending 1.4%. Czech Republic is spending 2.0% of their GDP. The second question is the Polish workers overseas. I have heard this question throughout my career. Are we having a brain drain in a country? Is the brain circulation a problem for us? And I will show you today some very interesting data that I think will surprise many of you. And the third is the level of commercialization and what I call the triple helix again, how academia, government, and industry are working together in Poland. And this is one of the numbers that I think would spur a lot of discussions. The reason why I put Edward Koffler here is that he was the writer of some theories that helped come up with what is called the fuzzy logic theories. The relationship between science and economy are not direct relationships. Not sure if you know this, the NIH in 1956 funded a piece of research. The NIH, the National Institute of Health, funded a piece of research that is the reason why we have smartphones in our pockets today. 65 years ago, that research was funded. It has nothing to do with health from an outcomes perspective. The amount of money that came into the economy of the US because of smartphones is, you cannot quantify that. So these are the issues that we have today in proving why science is important, because it's not an immediate one-to-one effect. So let me give you some of the numbers on Poland. Poland, over the last 5 years, have published around 230,000 articles. And the citations it received is around 1 million in total. And the authors around 130,000. The two numbers I will continue emphasizing as we go through the day are the following two numbers. Please remember this number. Your field-weighted citation impact. In other words, the quality of your publications in research are exactly equal to the world average. As it stands today, I will show you how that progressed over the last few years. So that is a good position. You are equal or slightly a little bit ahead of the average of the world. Not bad. Your average citation per publication is around 4.5 citations. And you're well-rounded when it comes to the types and disciplines that you do your research. Poland currently, out of the research that is being published, 11.6% of all the publications that are published by Poland are at the top 10%. So again, a little bit ahead of the world average. Publication in top journals, which is quite interesting to see, is around 17.2%. Again, a little bit ahead of the world average. International collaboration is 30%. 30% of all Polish publications are with international co-authors, equal to the world average. 1.3% is the academic corporate collaboration. That is low. So this is one of the first things that are below average that I would like to emphasize, and I will speak to that in a few minutes. This is how your map around the world looks like from a collaboration perspective. So you are collaborating quite vividly around the world, but with a strong focus across Europe. Is that good or bad? that is the second question you need to ask yourselves. So I'm very curious about collaboration myself. It has been scientifically proven that there is a multiplier of 1 for each international author you get added to a scientific paper. So the quality of the paper increases by 1 as you add international authors. So collaboration within one country is a factor of 1. Between 2 countries is a factor of 2. Multinational, multi-country research is a factor of 3. These are your primarily top 10 collaborators around the world. But I didn't like the top 10, so I extended a little bit. These are the top 13, because I was quite surprised, to be very honest. If you look at all the top 10, they are all Europe-based. I was really surprised. I have not seen a profile like that in a while, because the speed, as I mentioned, of growth that is happening in science now in the world is highest in Asia. So China, South Korea, Singapore, Australia, there is loads of investment, a lot of money. Japan, and all of them are also looking for collaborations. They have the same issue. They are only looking within Asia. They are looking for somebody who wants to reach out. Some of the best countries around the world doing that is Canada. So if you look at the extra 3 I added Canada, I added China, which are number 12 and 13 in your list from a quantity perspective. Bear with me a little bit with this one, and I hope you spend some time with me trying to analyze this. If you look at the top right-hand side, I am comparing the field-weighted citation impact of China alone to the field-weighted citation impact of Poland alone. In other words, the quality of Chinese publications compared to the quality of Polish publications, normalized. So 1 is the world average. If you are below 1, you are lower than the world average. If you are higher than 1, you are better than the world average. And then what I added in the middle between these 2 numbers is the publications co-authored between Poland and China. What is the citation? What is the quality of those co-authored publications? I did exactly the same for 4 countries. The top 2, and then I added China and Canada, number 12 and number 13, to tell you why you should ask yourself the most important question. Are you collaborating with the right collaborators? I heard a lot about grants. I heard a lot about win and success rates, about grants. The US currently has the lowest success rate in history when it comes to winning applications for funding. Scientists are leaving the domain of science because they are not able to get the grants. It's a global challenge. And one of the biggest ways to resolve that is to find the right partners, work together as a stronger team to win a better grant application. So let me go through this slide for a second. If you look at let me start with the US. The US is the first and most important collaborator with you currently as it stands today. So the US, which is the top right-hand side, you will see that the US field-weighted citation impact, quality if you will, is 1.45. Your field-weighted citation impact is 1.02. So very close, right? The publications that have co-authorship combined between you and them have an outcome of 2.8. Just realize what that means. When you work with your US partners, you give them a multiplier for quality of 2. They want to work with you. You have very strong researchers. You help the American research, and they help you. So yours goes from 1 in neutrality to 2.76 when you work with them, and theirs goes from 1.4 to 2.7. Look at the UK, top left-hand side. Theirs goes from 1.5 to 3.1. Interesting. They come third, but the multiplier is higher. So both you and them gain more than you collaborating with the US. Let's look at number 12, China. China has 0.85 quality. They are lower than the world average. You have one. You have a little bit higher than the world average on quality. When you work together, the co-authored papers between you and China have a quality metric of 3.53, higher than both US and the UK, while they rank 13th. Canada, which is quite amazing to see, is 4.3. They give you, if you work with the Canadian, a multiplier of 4, while you give them, a multiplier goes from 1.5 to 4. They are interested in working with you. You are interested in working with them. What is the right choice? I'm not here to answer that question. It's up to you. This is to answer the famous question of brain drain. Every country I go to, I hear that statement. We are having a very bad brain drain. The UK, with huge credit to the long vision I have seen in the community there, they actually saw it the other way around. And I will actually tell you the exact same position on your side. There is no such thing as brain drain if you use your networks right. Because if somebody leaves your country and goes somewhere else, and you maintain the connection, that is an asset. The UK has, let me start with this first. What you see on this slide are groupings of brain migration around the world, brain circulation. So the top group are people who leave Poland and go outside of Poland to work for more than 5 years. The lower one, second one, is non-Polish coming to Poland, staying for more than 5 years and then going back. The third one is what we call transitionary. People coming to work on projects. They come, either non-Polish come to Poland for less than 2 years and then the reverse. And then you have the fourth group, which is non-Polish coming to Poland for more than 5 years and Polish going outside of Poland, staying for more than 5 years and then returning. This is a lot of data. This report in itself can take weeks of explanation. I will try to sum this as I did on the left-hand side, in the most right-hand side here. So what you see here on the top right-hand side is what we call brain outflow. This means that the researchers leaving, let me take one step back, sorry. Poland has 65% of researchers who never leave. They are always in Poland. The quality of the research, and these are the ones that you see very low here on the top left-hand side, the quality of research is 0.7, below the world average. They never left. They are the biggest constituent of researchers, and they have the lowest quality. And that is very natural. That is exactly what I see everywhere in the world. Look at the ones who left Poland. 3.3% of those who left have double the quality. So they have 1.9, nearly 2 multiplier of quality. Quite interesting. They left and they did not return. The transitionary, which is quite surprising, and this is the group that I was quite impressed to see. You have 27.5% of your researchers are either coming from abroad or going abroad for only 2 years or less, working on very small projects. These are the biggest contributors to scientific disciplines. They have a quality aspect of 2. They are double your average and double the world average in quality, which was really quite interesting. The third group, which is different in yours, is the UK's most important group. They are the researchers who come from abroad, are non-British, and they stay for more than 5 years. The UK depends on the fact it sends its researchers outside, and they have high quality, and then they come back. But also it gets the best brains out of the world into the UK research world. You, on the other hand, are doing something quite unique. You are depending on transitionary researchers, and they are the ones adding the highest quality to your research, the middle group. This requires study, and I think it's something that would hopefully spark some discussions in the coming few days. I'll go very quickly now. These are just some examples of the Polish Academy of Science. The Polish Academy of Science currently is contributing around 25,000. Apologies. Sorry. The Polish Academy of Science currently contributes to around 25,000 articles, and the field-weighted citation impact, the quality impact, is around 1.15. So it is higher than the Polish average, higher than the world average. And it receives a citation per article of around 7.1. I looked at the second university of interest, which is Jagiellonian. They have half of the quantity, and their quality is around 1.17. So they have lower quantity, they have a little bit higher quality, and the citation per publication is around 7, so similar. And that is typical. You see usually academies of science produce high numbers and maintain high quality, while universities have that aspect of more focused science, less, but with high quality. And you see University of Warsaw, for instance, with the least from a quantity perspective, to my surprise personally, and with the highest quality, with around 1.23 field-weighted citation. And they have a same number of citation per publication, around 7. So quite an interesting profile. You have a very rich leading set of institutes that is supporting your science. And I did the same for just an example of University of Warsaw with Caltech. Caltech is, everybody wants to work with Caltech, right? But what I have heard in every travel I went out is, why would Caltech want to work with you? So this is the example. I did the exact same analogy I did on a country level, but comparing Caltech and Warsaw University. So you look at the quality of Warsaw University, that is here 1.3. You look at the California Institute of Technology quality, that is 2.5. The articles that you co-authored in Warsaw University with them has a quality of 5.2. You give them a multiplier of 2 on quality. You have a very good story to tell why they need to work with you and why you want to work with them. You gain more, of course, but you give them a double multiplier. That is not an easy thing to give to an institute like Caltech. Same I did with Jagiellonian and University College London, and it's the same logic. So you see that UCL has 2, goes to 4, and Jagiellonian has 1, goes to 4. If I compare Poland with some of the global peers in science, you see Russia, you see Poland, and you see Taiwan emphasized in this setting. These are the most 3 important ones I would like to highlight in this slide. So first of all, over the last few years, Poland is the one that has the red arrow pointing to it. You have managed to go from a quantity perspective of nearly 25,000 to a quantity of around 40,000. So the growth in quantity is quite significant. But if you look at Russia, over the last 2 years, because of the incredible investments they have done quite a steep growth curve. If you look at Taiwan, on the other hand, which is going down, they decreased and merged universities a few years ago, so you see a decrease in their actual quantity. A question, is that where you want to go? Because that is the natural order of things. If you maintain or decrease your funding, that happens. And if you look at Russia, over the last 2 years, they have extensively supported the research, like I've never seen them do before. On a quality basis, and I think you should be all very proud of the picture I'm showing you here. This is one of the most important slides I would like to show you today. Between the years 2000 and 2015, Poland has managed to increase the quality by nearly 30%. This I have seen across the world happen in 3 or 4 countries, including China as an example. You have grown your quality at the similar rate to China, but they went from 0.5 to 0.8. You went from 0.7 to 1. You are higher than China. Second most important item, if you look at the slide, you are where I show the arrow. The line below is Japan. Your current quality level is higher than Japan. You superseded Japan. Something to be really proud of, because I know how hard-working the Japanese are in trying to increase their quality to that aspect. But if you look at the second line upwards, you see Hungary. So Hungary is actually quite higher than you and Japan. If you remember my earlier number, they are putting 1.4% of their GDP into R&D. You are putting 0.95. That is a big difference. In the corporate world, we are always asked, before we ask for more money, are you efficient enough? Are you doing enough with what you have? I'm trying to answer that question in this slide. Are you efficient enough from an R&D perspective? I have 1 more minute to go. Poland is currently receiving 95 citations per $1 million. Germany is receiving 50. You are nearly double Germany from number of citations per $1 million. Having said that, Hungary, which spends more than you do, is receiving also the same number, 95 more or less citations per $1 million. So again, comparing you to Hungary is quite important, because it tells you that they are having the same efficiency, but they are spending more than you are. If you manage to get your GDP expenditure R&D from the current 0.95 to 1.4, you would be the number 18th country in the world when it comes to research net expenditure. That is even lower than your commitment by 2020. This would put you as a G20 of scientific research. This is my last slide. I will not go too much into this. It is the number I showed you a few seconds ago. It is about your industry and patent efforts. You are doing significantly lower than the world average. The number of patents you see is way lower than the norm. Germany has 24,000, Italy has 11,000, Taiwan has 5,000, you have 2,000. You have to start looking at how to enhance that, and we can help you with this. This is just an example of how you can match your own authors with corporate authors. Companies want to publish. They do publish. I give you a very small example. I chose by random here the 4th potential candidate. The tools that we have algorithmically connect the researchers in Poland with the right matches on the industry side. So if I look here, you can look at potential collaborators in the University of Warsaw using the tools, and then it gives you the expected outcome, and it also gives you the names of the people on both sides that you want to make sit together. The idea is, and we have done that in Japan, in the US, we do speed dating events between researchers, university, as well as industry university. We introduce them to each other. We tell them why the algorithm is saying that they should work together, and then we leave them to do that. With that, I conclude. I sum up the 4 questions that I hope I sparred today. The first is Poland making the right investments in research? The second is, what drives your collaboration strategy? Are you collaborating rightfully with the US as number one? Or should you revise that and maybe it's Canada? I don't know. Are you making the right use of your mobility and network? Instead of thinking that we have a brain drain, maybe if we apply that drain in a similar fashion like China and India have done, this ends up to be an actual network that supports your research. And the last one is, what is your triple helix strategy? How are you going to make sure that academia, government, and industry are connected to the extent that commercialization of the research helps reinvest in research? I thank you for inviting me to this great conference, and I'm very happy to be part of it, and I hope that discussions continue, so please reach out to me after the discussions if you need to. Thank you very much.